Hello everyone, welcome in channel of Mr. Statistician. Today we will discuss result related to F distributions. Let's begin. If x follows F distribution with n1, n2 degree of freedom, then its probability density function fx of x is equal to n1 upon n2 raised to n1 by 2 upon beta n1 by 2, n2 by 2 into x raised to n1 by 2 minus 1 upon 1 plus n1 upon n2 into x whole raised to n1 plus n2 by 2 for x is greater than 0 and f of x comma y is equal to 0. Otherwise, first result is if x follows chi-square with n1, y follows chi-square with n2 and x comma y are independent, then y is equal to x upon n1 divided by y upon n2 equal to n2 upon n1 into x upon y follows F distribution with parameter n1 comma n2. How to remember this result? Here y is equal to chi-square random variable with n1 degree of freedom divided by its degree of freedom is n1 divided by second random variable is chi-square with n2 degree of freedom divided by its degree of freedom is n2. This follows F distribution with parameter n1 comma n2. So we remember this result in this form, that is chi-square with n1 divided by its degree of freedom n1 whole divided by chi-square with n2 divided by its degree of freedom is n2. Second result is expectation of x equal to n2 upon n2 minus 1, which is greater than 0, which is independent of n1. Here expectation of x equal to n2 upon n2 minus 1. Here in the F distribution, two parameter n1 and n2, these are two degree of freedom n1 and n2. Here only n2 is present in expectation of x, n1 does not present, therefore expectation of x is only depend on n2, does not depend on n1. Also here expectation of x is equal to n2 upon n2 minus 1 is greater than 1 and mode is less than 1 for this distribution F with n1 comma n2 degree of freedom. Third result is x follows f with n1 comma n2, then y equal to 1 upon x follows f with n2 comma n1. Here see x follows f with n1 comma n2, then 1 upon x, that is reciprocal of x is taken, then this follows f with degree of freedom is changed, that is n2 is first degree of freedom and n1 is second degree of freedom. This is a most important result. Fourth result is if x follows t distribution with n degree of freedom, then x square follows f distribution with 1 comma n degree of freedom. Fifth result is if x follows f with n1 comma n2, then n1 into x follows chi-square with n1 as n2 tends to infinity. Here see n1 is here and then chi-square degree of freedom is also here, but n2 tends to infinity, n2 does not present in this. Always remember. And sixth result is if x follows f with n1 comma n2, then n2 upon x follows chi-square with n2 as n1 tends to infinity. This result is combination of two results 3 and 5. Here result 3 and result 5. From here given that result in 6, x follows f with n1 comma n2, then from result 3 let y equal to 1 upon x follows f with n1 n2 comma n1, and here y follows, from this y follows f with n2 comma n1. So from result number 5, here x means y random variable, we consider f follows f with n2 comma n1. Here parameter is interchanged. From this result n1, here first parameter into x, therefore here first parameter is n2, so n2 into x, here x not x, here y, because y follows f with n2 comma n1. This follows chi-square with n1 degree of freedom, and the first degree of freedom means here first degree of freedom is n2 follows chi-square with n2 as n1 tends to infinity, because here second parameter is tends to infinity, here second parameter is n1 tends to infinity. This implies that here x follows f with n1 comma n2, then n2 into y, that is equal to n2 into y is 1 upon x, that is n2 into 1 upon x, that is n2 upon x follows chi-square distribution with n2 degree of freedom as n1 tends to infinity. This is sixth result. So seventh result is, if x follows t distribution with n degree of freedom, then x square follows chi-square distribution with 1 degree of freedom as n tends to infinity. This result is also combination of two results, result 4 and 5. Here result 4 is and result 5 is. Seventh result is, if x follows tn, that is here given that x follows tn, so by fourth result is x, therefore y equal to x square follows f with 1 comma n by fourth result. And then by fifth result says that x follows f with n1 comma n2, here y follows, that is y equal to x square follows f with 1 comma n. Then from fifth result, n1 into x, that is first parameter into this random variable, here first parameter is 1 into random variable is y, that is equal to y. This follows chi-square with first parameter, that is first parameter here is 1 degree of freedom as second parameter tends to infinity, that is n tends to infinity. This implies that if x follows chi-square, x follows t with n degree of freedom here, then by result 4 and 5, y, that is equal to x square follows chi-square with 1 degree of freedom as n tends to infinity. Here we see result number 4 and result number 7, we see both results are same, but in result 4 n is not large and in result 7 n is large. That is, if n tends to infinity, then x square tends to chi-square, that is distribution of x square is changed for large n. Then result number 8 is, if n equal to n1 equal to 1 and n2 equal to 1, that is both degree of freedom n1 comma n2 are similar and which is equal to 1, then this distribution is similar to beta distribution of first kind with degree of freedom is 1/2 comma 1/2. Here degree of freedom is not called beta distribution, here parameter is 1/2 comma 1/2. Here we know that here n1 equal to n2 equal to 1 is given, therefore x follows f with n1 comma n2, that is n1 comma n2 is 1, that is x follows f with 1 comma 1, therefore its density function is equal to n1 upon n2 raised to n1 by 2, here 1 upon 1 raised to 1 by 2, that is into x raised to n1 by 2, that is 1 by 2 minus 1 upon beta 1 by 2 comma 1 by 2 into 1 plus n1 means 1 by 1 into x raised to n is 1 plus 1 divided by 2. From this is equal to x raised to 1 by 2 means 1 by 2 minus 1 equal to minus 1 by 2, that is 1 upon x raised to 1 by 2 into 1 upon beta 1 by 2 comma 1 by 2 into this is equal to 1 upon 1 plus x raised x. This is equal to, we not written in this form, we write it this similar form, that is equal to 1 upon beta 1 by 2 comma 1 by 2 into, from this is x raised to 1 by 2 minus 1 upon 1 plus x raised to 1 by 2, this 1 plus 1, that is 1, and we know that this density function is a beta distribution of second kind with parameter 1/2 comma 1/2. That's why for n1 equal to 1 and n2 equal to 1, that is both degree of freedom of f distribution are similar and equal to 1, then this distribution is similar to the beta distribution of second kind with parameter 1 by 2 comma 1 by 2. Ninth result is moment generating function of f distribution does not exist, but its moment exists. Here see, we know that expectation of x is equal to mu 1 dash, that is a moment about origin which is equal to 0. So moment is also exist here, variance is also exist, therefore the moments exist but moment generating function is not exist.